My name is Jeff Bartels, and in my part of the presentation, we'll be exploring a multitude of Civil 3D tips and tricks. In fact, my goal is to cover as many as 20 tips in the next few minutes. To do that, I'll be using a shotgun approach so we can get through as much material as possible. On screen, you can see a rough outline of the categories I've chosen to organize my content. I believe content like this is valuable for the following reasons. By definition, tips, tricks, and shortcuts can make us more efficient users of Civil 3D. Likewise, they represent workflows that aren't covered during typical training courses. Many times, content like this is the type of stuff you pick up on your own over a lifetime using the application. Finally, it's always nice to discover tools or concepts that you may not have known were there. All right, we've got a lot to talk about, so I'm going to flip over to Civil 3D and we'll get started. Right off the bat, let me mention that everything we look at today should work for you regardless of the version of Civil 3D you may be using. In the interest of full disclosure, let me mention that I'm using Civil 3D 2021.1. On my screen, I've got a drawing that represents a portion of a proposed roadway design. To zoom in and out, I can roll the mouse wheel forward and back. Did you know that we can control the amount of zoom that we get with each movement of the mouse wheel? There is a system variable called zoom factor. I'm going to type that in and I'll press enter. As you can see, the default value is 60. The lower the number, the less zoom you get with each movement of the wheel. The higher the number gives you more movement. As an example, I'm going to set this to 10 and I'll press enter. Now, as I roll the wheel forward and back, you can see I have a much more granular level of control when it comes to zoom. Let's go back to the system variable. I'll right-click and choose zoom factor. At this point, you may be wondering what the valid range of numbers is that we can use for the system variable. For instance, how high or low can we go? Fortunately, we don't have to look it up. All we have to do is type in a number that we know won't work. For this example, I'll type 1 million and I'll press enter. When I do, we can see that zoom factor requires an integer between 3 and 100. Now, I used this trick with zoom factor, but it'll work with any system variable. I'm going to flip this back to 60 and I'll press enter. Since we're talking about zoom, I'm sure you're aware if you come over to the Prospector tab, you can right-click on your civil objects over here and choose Zoom To from the menu. For instance, I just zoomed in on a surface. Let's come over to Alignments. I'll right-click on an alignment and I'll choose Zoom To. Unfortunately, this Zoom To feature doesn't work with every Civil 3D object type. For instance, I have several feature lines in this model that represent the top and bottoms of these retaining walls. Here in the Prospector, if I drag down and find the Sites category, I can expand the retaining walls, and if I choose the Feature Lines group, we can see all of the named feature lines below. If I right-click on the group, there's a Zoom To option, although that's kind of anticlimactic because it's zooming in on all of the feature lines. Knowing that, if I right-click on an individual feature line, there is no Zoom To option. We can get around this by choosing Select. Once we select the feature line, we can then come up and click the top hotspot on the view cube to zoom to that location on screen. I'll press Escape to deselect. I did this with a feature line, but it'll work with any object that you can select in your file. If you click the top hotspot on the view cube, you can zoom right to that object. Let's back up and we'll center the drawing. If you're someone who incorporates geospatial data into your models, you're probably familiar with the Map Task Pane. Historically, to bring up the pane, we would type Map W space and then press Enter to display the palette. Let's close this. A few years ago, that particular command was added to the ribbon. If we go to the Home tab and expand the Palettes panel, we'll find an icon for the Map Task Pane here. If I click that and press Enter, we can bring up the palette. Once again, I'll close this. Now, the drawing I have on screen includes an external reference. I'm going to select it. Maybe I'd like to open this drawing. I'll do that by right-clicking, and from the menu, I can choose Open XREF. When that drawing is opened, you can see it contains the utilities for this model. I'm going to make a quick change. I'll do that by selecting this structure. I'll click the grip and I'll move it. I'll press Escape, and when I'm finished, I'll come up and click Save. I will then click to return to the original drawing. And when I do, we get this notification bubble down in the corner that lets me know that an external reference was modified. Typically, we see these notification bubbles when things that we've attached to have changed. External references and data shortcuts are a good example. These notification bubbles stay up until such time as I come over and click the X to close them. It doesn't have to be this way. We can have the bubbles close on their own. There is a system variable called Tray Settings. As you can see, by default, notifications will display until closed. I'm going to flip this to Display Time Over to the right, I can determine the number of seconds I'd like the bubble to be on screen. Let's keep the default of 5, and I'll come over and click OK. Now I will have to close this one manually, but from now on, as things change, those bubbles will pop up. They'll remain on screen for 5 seconds, allowing me to recognize that they're there, and then they will close on their own. Note that you may have to close Civil 3D and reopen for that change to take effect. Let's look at another drawing, and we'll explore some tips and tricks associated with dimensions and measurements. On screen, I have a portion of an intersection design. Let me zoom in. Let's say I'd like to apply a note to this painted label. Since this is not a civil object, I am going to use a multi-leader. I'll click multi-leader, I'll click on screen, and then I'll pull this out and click. And then for this example, I'll just type note and click on screen. As we add notes and dimensions to a file, it can get busy, and the intersection of these objects can create confusion. Fortunately, we can create dynamic breaks to simplify things. Here on the Annotation Ribbon tab in the Dimensions panel, I'm going to click the Dim Break button. I can then select the dimension I'd like to break, followed by the object I'd like to use to break it. I'll press Escape when finished. Now when I grab this label, you can see that as I drag this around, that break is dynamic to that dimension. Let's drag it over here. When I do, you'll notice that we don't see a break. There actually is a break there, but there happens to be 2 dimensions as well. Let me press Escape. The Dim Break command includes a multiple option. I can use that to select multiple dimensions. I'll press Enter, and then I will select my object to create the break. Once again, I'll press Escape, and then as I pull this out, you can see how it affects those dimensions. Now, you may be wondering, will this work with Civil 3D labels that are in a dragged state? Unfortunately, it will not. So this trick is not going to be suitable for every situation. That said, no trick ever is. I'm going to select this label one more time and we'll drag it out. As our drawings become more busy, we may have no choice but to place labels in an area where we have congested line work. Now, Civil 3D labels have a masking feature to hide the objects behind the text. We can do the same thing with our multi-leaders. As an example, I'm going to select the multi-leader, and here in the Properties palette, I'll come down to the text group. From here, I will expand the background mask setting and change this to yes. When I do, you can see it's hiding everything behind the label. After seeing that, you may be wondering if this will work with dimensions as well. And it will. Let's drag this dimension out. To mask dimensions, we'll come over to the Properties palette, and then I'm going to roll the mouse wheel down till we get to the text area. From here, I will adjust the fill color to background. That applies a similar masking to the label. I'm going to zoom out. We'll pan the drawing over. When we're working in Civil 3D, we are frequently editing and creating objects that are in 3-dimensional space. On my screen, I have a pair of objects. We have a circle and a polyline. These objects are in 3D. Let's do a quick orbit to verify that. I'll hold the Shift key and the mouse wheel and push forward to orbit the drawing. We can see those objects exist in 3D space. When I'm finished, I will release my fingers from the buttons. And to restore the original view, I'm going to type ZP, stands for Zoom Previous, and press Enter. Even though I didn't use Zoom to adjust the view, I can use Zoom Previous to get back. When working with 3D objects, we may wish to identify the shortest horizontal distance between them. For instance, how far is this utility from a property line? How far is this roadway feature line from a wetland boundary? To take that measurement, I'm going to go to the Analyze ribbon tab, and then I'll expand the Inquiry panel, and I'll choose Minimum Distance Between Entities. I will then select my first entity and the second. I can then choose to draw the shortest distance line so I can see where that measurement was taken. When finished, I'll press F2 to bring up the command line history, and right here we can see the minimum distance. We can also see the coordinate where it was measured from on the first and second entities. Let's close this, and then I will select this line and I'll press Delete. We can find minimum distance horizontally or vertically. I'm going to move the polyline. I'll just type M for move and press Enter. I'll select the polyline, and then we'll pick this up from a point on screen, and I'll place it right here. Once again, I'm going to come up to the Inquiry panel, and I'll choose Minimum Vertical Distance Between Entities. This will identify the distance between the objects where they intersect. The way this works, you click the first object closest to your desired intersection, because there may be more than one, and then click your second object close to the intersection. I'm going to choose to draw the shortest distance line, and then I'll press F2 to bring up the command line history. I can see these objects are a little more than 67 feet apart. I can see the elevation of the circle at that location and the elevation of the polyline, and I can see the coordinates of the intersection. When finished, I'll close the dialog box. Let's orbit the drawing again. I'll hold down Shift and the mouse wheel. We can see where that measurement was taken. And then we'll go back to our previous view by typing ZP, and I'll hit Enter. I will then clean up after myself. I'll select this geometry and press Delete. In case you're wondering, I've provided a list of entities that support the minimum horizontal and vertical distance commands. Let's pan the drawing over, and we'll talk for a second about conversion. Specifically, how we can convert objects into polylines. On my screen, I have a line segment. Let's say that I'd like to convert this into a polyline such that I can apply a width to maybe represent a painted stripe in the roadway. Normally, to convert this to a polyline, we'd launch the pedit command. We don't have to. In Civil 3D, you can select a line or arc, and in the right-click menu, you'll find the Convert to Polyline option. Now that this is a polyline, I'd like to apply a width to it. Once again, you'd think that we'd go launch the pedit command. We don't have to. Just for a second, think about how we edit text in the AutoCAD platform. We double-click on it. We can edit polylines the same way. I'm just going to double-click, and it brings up the properties of the pedit command here at my cursor and down at the bottom of the screen. Let's choose width, and I will set this to 2 and press Enter. I'll press Escape when finished. Let's talk about arcs. If you've ever applied a line type to an arc, you've probably noticed that the line type tends to go in one direction only. To reverse this, I'm going to do it by converting the arc into a polyline. I'll do that by selecting the arc. I'll right-click and choose Convert to Polyline. Once it's been converted, we'll edit the polyline by double-clicking on it. And from here, I'll choose Reverse. Now we have to do one more thing. I'll choose Line Type Generation. Typically, we use line type generation to span a line type across all the segments in a polyline. If we're dealing with a single arc, though, this also works well to display the reversed direction of the line type. When I'm finished, I'll press Escape. If you're interested in other conversion options, if we go to the Modify Ribbon tab and expand the Design panel, you'll find tools here that we can use to convert from 2D to 3D polylines and back. Let's talk about splines. On occasion, we may see splines when we receive drawings that were created by applications other than AutoCAD. We can easily convert splines into polylines as well. In my example, I have a pair of splines. These are planar, so the Z elevations of all the vertices are the same. To convert this top one into a polyline, I'll double-click on it. This launches the SPL Edit command. From here, I'll choose Convert to Polyline. I can then enter a precision. The lower the number you enter, the closer the polyline will match the original geometry, but the more grips you'll have. Higher the number, you'll have fewer grips, but it won't match the geometry as well. For this example, I'm going to press Enter and accept the default. I will then select the resulting polyline, and you can see the grips on screen. Generally speaking, using this method, it converts the spline into a polyline made up of short, straight segments. Let's back up. Sometimes, if you're working with planar splines, a better way to convert them is by using the Flatten command. Flatten is an AutoCAD tool that's used to convert 3D geometry to 2D. I'll type Flatten and I'll press Enter. I will then select this spline and press Enter. Note that I'm asked to remove hidden lines. In the event this object was in 3D and I had entities that were coming straight towards me, they would be hidden from my view. I don't have any of that, so I'm just going to hit Enter and accept the default here. And if I select the resulting polyline, you can see that it's got fewer grips, it matches the geometry better, and the entities are actually curves. Let me press Escape, and then we'll back up. Let's jump to another drawing, and we'll look at some tips and tricks having to do with points. This file represents a portion of a proposed subdivision design. If I zoom in, you can see I have several survey points that were used to collect this existing roadway. I've got other points that were placed to identify property corners for the purpose of staking these out in the future. Let's back up and we'll pan the drawing over. Here on the Prospector tab, if I expand the Point Groups area, we can see the point groups that are used to organize the points in this file. I'm sure you're aware if we add or remove points, it will require us to update any of the affected point groups. As an example, I am going to select a couple of these Kogo points, and I'll press Delete. You can see the shield shows up next to that point group. From here, we would right-click and choose Update to update the point numbers in that group. Note there's also a Show Changes option. If I select this, it will show me exactly what it's going to do to update that group. As you can see, it's removing some points. If there were points added to the drawing that are going to be placed in the group, it would show me that as well. Let's click Close, and then I am going to update this point group. Now, let's say I'd like to export these Kogo points such that I can give them to the survey crew. Historically, that would mean going to the Output tab, I would choose Export Points. In the Export Points dialog box, I would select my format, my destination file, and right here I would select the point group I'd like to export, as well as some other things, and then I would click OK. We can actually do it a little bit faster. If you come over and right-click on the point group itself, from here you can choose Export Points. It'll bring up the same dialog box, and it will eliminate one of the settings that we would have to make. Let's close this, and I'll pan the drawing up. When working with survey points, it's important that each point has a unique number. When the survey crew goes out to collect new data, you may wish to identify available point number ranges that they can use. There is a command called List Available Point Numbers. If I type that in and press Enter, I can see all of the available point numbers that remain in the survey database. Let's press Escape. We can also go the other way. I can type List Used Point Numbers and press Enter. This shows me all of the point numbers that are currently occupied in the survey database. I'll press Escape when finished. Let's jump to another drawing, and we'll look at a couple tips and tricks having to do with profiles. On my screen, I have a profile view that contains a layout profile. Let's label this. I'll do that by selecting the profile, and then from the ribbon I'll choose Edit Profile Labels. I will then select Import Label Set, and then I'm going to choose Complete Label Set. This is the label set that comes out of the box with Civil 3D. I will then click OK and OK. I'll press Escape. When we review the labels, we can see that all of the crest and sag curve labels appear here at the top of the profile view. Let's find out why. I'm going to select the profile again, and we'll go back to Edit Profile Labels. Here in the label set, if we look at crest curves and sag curves and come down to the Dim Anchor option, you'll see that both of these are set to Graph View Top, which is where we see the labels on screen. Instead, maybe I would like the crest curves to be placed a specific distance above the vertical curve. Maybe we'll make that 3 inches. And then maybe I'd like the sag curve labels to be placed a specific distance below the vertical curve. Once again, I'll go with 3 inches. When finished, I'll come down and click Apply and OK. Notice the difference? By applying these settings to the default label set that you use, you can place labels just like these automatically. Now I show you that to show you this. If I select a crest curve label, which is now set to above the curve, and click a grip, you can see I can't pull it past the profile. Let's press Escape. For this tip, I'm going to edit this crest label. If I select it though, you can see that all of the crest labels are selected. This goes the same for the sag labels. Let's press Escape. To adjust this label only, I'm going to hold the Control key and select the label. When you use Control, it allows you to select an individual entity, even if it's part of a group. Once that label is selected, I'm going to come over to the Properties palette, and right here you can see the Dimension Anchor option is set to default. I will set this to Below. As you can see, the label is now below the curve, and if I select the grip, I can now drag it up and down from here. I'll press Escape. We'll pan the drawing over, and we'll look at a couple tips associated with parcels. If I zoom in, you can see I have several parcel styles here. This particular parcel is using a style suitable for lot boundaries. This one is suitable for the right-of-way, and this one would be used for single-family lots. Let's back up. Here, I have a site that's subdivided into 3 parcels. Just for a second, let's select this parcel that represents the right-of-way. I will then come over to the Properties palette, and you can see that a right-of-way parcel style has been applied. That means that parcel should look like this, although it doesn't. Keep that in mind. I'll show you how we can solve that in just a minute. First, I'd like to show you how we can subdivide these lots. To do that, I'm going to go to the Home tab, and then I'll choose Parcel. I'll choose Parcel Creation Tools. By default, when we set our minimum area, we do that in square feet, although we don't have to. Let's assume that each lot I create will have a minimum area of 1 acre. If I'd like to enter acres into this field, I will type in the number of acres, followed by the word acre, no space between them. When I press Enter, you can see it calculates that value into square feet. For this example, I'm just going to use Slide Line Create. I'm going to put these parcels in the subdivision site. They're going to be using the single family style. Let's click OK. I will subdivide this parcel, and then I will pick the endpoint here of the right-of-way to the endpoint down here to represent my frontage. And then for the angle, I'm going to press Enter to accept 90 degrees so that the lot lines are 90 degrees to the right-of-way. I'll press Enter again to accept. Let's subdivide this parcel as well. I'll select it, and then we'll grab the two endpoints for our frontage. Press Enter and Enter. And if we zoom in, you can see I have a bunch of perfectly sized 1-acre lots, until of course we get to the end here, and this matches our settings. Place any remainder in the last parcel. I'm going to press Escape when finished. We'll pan this over. And for our final tip, we'll look at how to control the display of overlapping parcel styles. Here on the Prospector tab, I'm going to expand the Sites category and expand Subdivision. Right here is the Parcels group that contains all the parcels that we see within this site. I'm going to right-click on the Parcels category, and from here I'll choose Properties. On the Composition tab, I can assign a parcel style to the overall site, so this parcel style would apply to the outside edge. Lot boundary is perfect in this case. That would make the parcel look like this. Down below, in the parcel style display order, we can see the parcel styles represented in the parcels within this lot. Notice that they all look like single family. That's because single family is on top. I'm going to grab the lot boundary parcel style, and I will push this to the top. So in the event lot boundary shares a property line with another parcel, lot boundary will appear on top. Let's grab right away, and I'll push that up. Right away is going to be less important than lot boundary, but more important than single family. When finished, I'll come down and click OK, and you can see the change on screen. Lot boundary is now what we see around the outside of the site. I can then see my right of way, and I can see the lot lines representing single family lots. With that, I think we've exceeded our 20 tips for this part of the session. On behalf of Jerry, Alan, and myself, I want to say thank you so much for attending our AU class. Be sure to fill out the survey and let us know how we did. There's no better way to get more of what you want and less of what you don't than to be brutally honest when filling out your surveys. Thanks again. If you're interested in more content like this, please visit us at the Civil Immersion blog, where you'll find hundreds of recorded workflows covering many of the tools in the AEC collection, with new content being posted regularly.